Hey everyone, in this video we're going to try to run through the rest of section 1, or I guess chapter 1, for our Math 152. We left off with an example last time where we were stating a few particular pieces of this study, essentially. We're going to continue on with another example before we go ahead and move on here. In this example, we're asked, a parking control officer records the manufacture of every fifth car in the college parking lot in order to guess the most common manufacturer. State the unit of observation, variable, population, and sample. We're also going to state the parameter and the statistic. So here, our unit of observation is one car in the parking lot. Unit of observation is going to be a car in the college parking lot. Our variable is going to be the name of the manufacturer. This is again a qualitative variable because we're recording a car type. This is a qualitative variable. Our population this is the set of all names of the manufacturers of cars in the college parking lot. Because in this case, we're studying cars in the college parking lot, right? We're not studying every car. So our population is the set of all names of the manufacturers of cars in the college parking lot. The sample is going to be the set of recorded names of the manufacturer of the cars in the college parking lot. So the sample is going to be the set of names that you end up actually recording. Remember that this is not the entire population, because in this case we're only recording the manufacturer of every fifth car. Now, for our parameter, remember this is our quote-unquote true value, right? Our parameter is going to be the proportion of each car type calculated from the population. And our statistic, this is going to be the proportion of each car type that's calculated from the sample. Remember, our statistic should be an estimation of our parameter. Since most of the time we can't survey the entire population, we can't typically find the parameter. Let's look at another example here. A biologist wants to estimate the average height of a plant that is, I don't know why there's a greater sign here, given a new plant food. She gives 10 plants the new plant food. We want to do the same thing. State the unit of observation, the variable, the population, and the sample. So maybe this time I'll type. Let me see. Text size. I need to increase that. I'm looking at my OBS here. This is the one thing I didn't. Let's see, text size. This looks good. So that was 36. So our unit of observation here. Let's read this again. A biologist wants to estimate the average height of a plant that's given a new plant food. She gives 10 plants the new plant food. So our unit of observation is going to be a plant that's given the new plant food. Our variable here, this is going to be the height of the plant. And in this case, this is a quantitative variable. This is a quantitative variable because we have a number. We have a measurement here, right? The past two were qualitative variables because the data that we were collecting was in the form of a word or a quality of something rather than a number or a measurement of something. But now that we're dealing with measurements or numbers, these are quantitative variables. Our population here. This is going to be the set of all the heights of plants when the new food is used. I guess when fed the new food. I guess quote unquote fed, right? As much as I suppose plants eat, right? Our sample here is going to be the set of the heights of the 10 plants that we gave the new plant food. So our sample here is just these 10 plants that we're talking about in particular. These 10 plants that the biologist gave this plant food. Our parameter. This is going to be the average height of all plants when the new plant food is used. Because here the biologist wants to estimate the average height of a plant that's given a new plant food. So the parameter is going to be the average height of all plants when the new plant food is used. Our sample, and I guess notice the difference here between our variable and our parameter, right? Our variable is the actual measurement of each plant. Our variable is not an average. But our parameter is this average. This is because the parameter is something that is calculated from the population. So the parameter isn't just our measurements here. This is something that's calculated. our statistic is the average height of the 10 plants that the biologist fed the plant food. When the, let's see, how should we phrase this? The average height of the 10 plants when the new plant food is used. And when we say the 10 plants here, we're referring to the 10 plants that this biologist is looking at, of course. And this, sorry, I didn't mean to type sample here. I meant to type statistic, not sample. This is because I was talking about how the parameter was calculated from the population, so I was about to talk about how the statistic was calculated from the sample. Sorry. And this statistic is, once again, an estimation of the parameter. Awesome. Let's move on to our next example here. A doctor wants to see if a new treatment for cancer extends the life expectancy of a patient versus the old treatment. She gives one group of 25 cancer patients the new treatment and another group of 25 the old treatment. She then measures the life expectancy of each of the patients. State the individuals, variables, populations, and samples. So, in terms of, when we say individuals here, we're really referring to units of observation. We really have two different units of observation here, right? Since we have two different units of observation, this means that we also have two different variables, two different populations, two different samples, and two different parameters. So let's increase our text size to 36. So again, when it says state the individuals, we're really looking at stating the units of observation. We have two of them in this case. So unit of observation 1. This is going to be a cancer patient that's given the new treatment. Or you could say cancer patient given the old treatment and make unit of observation 2 the other one. Let me, I think I was in the same text area as this thing up here, so I had to copy paste. Our unit of observation number 2 is going to be a cancer patient given the old treatment. These are two different groups that we're looking at and comparing, right? So this is why we have two different observations. We have two different groups that we want to compare to one another. So after this, anything I give the number 1 is going to match up with this first unit of observation, the new treatment. And then once I give it a number 2, it's going to match up with the unit of observation number 2, the old treatment. So our first variable, our variable for the new treatment, this is going to be the life expectancy when given the new treatment. Because this is a number, this is quantitative data. I can't expand this. Okay, I can expand it more. There we go. Now variable 2 is going to be the life expectancy when given the old treatment. This again is quantitative. This is a quantitative variable. The first population here is going to be the set of all life expectancies of cancer patients given the new treatment. And our second population is going to be the set of all life expectancies of cancer patients given the old treatment. So as a result, I'm going to move this down a little bit to try to keep this in view as we're getting through the rest of these. We still want to get to samples. And then, of course, we want to list our parameter and our statistic as well. Our first sample, our sample that involves the cancer patients given the new treatment. This is going to be the set of the 25 life expectancies of cancer patients given the new treatment. Our second sample is going to be the set of the 25 life expectancies of cancer patients given the old treatment. So our first parameter, this is going to be the average life expectancy of all cancer patients given the new treatment. Our second parameter is going to be the average life expectancy of all cancer patients given the old treatment. And our statistic, let's see, 1, 2, 3, 4, 6, okay. Our statistic, our first statistic, this is going to be our estimation of this first parameter that we find from our sample. So in this case, it's going to be the average life expectancy of the 25 cancer patients that we studied given the new treatment. And statistic 2 is going to be an estimation of parameter 2. It's going to be the average life expectancy of the 25 cancer patients given the old treatment. Again, this is an estimation of our first parameter. Now, there are different types of, I meant to type quantitative variables, not qualitative variables. There are different types of quantitative variables called discrete or continuous variables. The difference is in how many values the data can possibly have. If you can count the number of data values, even if you're counting to infinity, then the variable is called discrete. If it's not possible to count the number of data values, then the variable is called continuous. So discrete data can only take on particular values like integers. So like -1, 0, 1, 2, 3, right? Discrete data are usually things that you count. So for instance, discrete data might be something like the number of cars in a parking lot, right? You count the number of cars in a parking lot. Continuous data. Continuous data can take on any value. Continuous data are usually things that you measure. So Let's see. For continuous data, um, continuous data might be the height of a person, right? Obviously, there are going to be restrictions to, um, exactly how tall a human can be, right? But this is still a continuous variable. You can't really count the number of different heights that a person can take on. Let's look at classifying some of these. Let's classify each of these as discrete or continuous. First up is the weight of a cat. The weight of a cat, this is continuous because this is something that we measure. The number of fleas on a cat. The number of fleas on a cat is discrete because this is something that you count. The size of a shoe. Now, when we think about the size of maybe a foot, the size of a foot might be continuous. But shoes only come in certain sizes, right? Shoes only come in size like 7, 7.5, like 11, 12.5. Sometimes you have like wide variations, or sometimes maybe even more narrow variations within here. But shoes come in particular sizes. You can't buy a size, 11.793 shoe. You can't buy a shoe of this size. So as a result, this is discrete. Again, this is because shoe sizes can only be certain values. There are also 4 measurement scales for different types of data. Each of these measurement scales builds on the measurement scales that come before it. So there we have nominal. On a nominal measurement scale, data is just a name or category. There's no order to any data since there are no numbers and you can't do any arithmetic on this level of data. Examples of this are things like gender, car name, ethnicity, and race. Ordinal measurement scales. Here, for ordinal data, this data is nominal, but now we can also put the data in order, since one value is more or less than another value. You cannot do arithmetic on this data, but you can now put data values in order. Examples of this are grades, like A, B, C, D, F. You can't do arithmetic on that, but you can place them in order. Place value in a race, and size of a drink. Interval data is data that's ordinal, but now you can subtract one value from another, and that subtraction makes sense. You can do arithmetic on this data, but only addition and subtraction. So examples of this are temperature and time on a clock. And ratio data. Ratio data is data that is interval data that can now, where now we can also divide one value by another, and that ratio makes sense. You can now do all arithmetic on this data. So examples of this are height, weight, distance, and time. And let's look at a few examples here. Let's state which measurement scale each of these is. For A, we have time of our first class. I suppose, sorry. I actually skipped over something first. This is important. So a lot of people have a hard time deciding if data are nominal, ordinal, interval, or ratio. Well, nominal and ordinal data, these first two types, these usually come from qualitative variables. Interval and ratio data come from quantitative variables. So that's the first thing that we can do to try to determine if something or what type of data something is. So where was I? Sorry. So determining whether something is qualitative or quantitative lets us sort between nominal ordinal or interval ratio, right? So if our variable is qualitative, for instance, if our variable is in terms of words instead of numbers, then it has to be either nominal or ordinal. At that point, we have to ask ourselves, can we put that data in some kind of order? If we can put that data in order, then it's ordinal. If we can't, then it's going to be nominal. Now, if our variable is a number, if it's quantitative, then it has to be either interval or ratio data. For ratio data, a value of 0 means that there is no measurement. So for ratio data, this is important. A value of 0 means that there is no measurement. For instance, in the examples given here, like height, someone can't be like 0 inches tall, right? You can't have no height. If you see a height of 0, just absolutely 0, then that means that there's no measurement, right? Or if you have $0 in your bank account, it means that you don't have any money, right? So that's a big distinction between interval and ratio data. So basically, if there's no absolute 0 like that, or if the 0 does not mean that there is no measurement, then we're looking at interval data. So let's try to state which measurement scale each of these is. The time of our first class. So time is a number. Now we have to ask ourselves, what does a 0 represent in terms of time? Does a 0 represent no measurement? No. A 0 just represents midnight whenever, whenever we're talking about time. This means that this is interval data. Hair color. So hair color is not a number. So this is a qualitative variable. Because this is a qualitative variable, this has to be either nominal or ordinal. But there's no particular order for hair color. So as a result, this has to be nominal. The length of time to take a test. This is a number. And if you take 0 minutes to complete a test, it just means that you didn't take the test. So a measurement of 0 here means that there's no measurement. As a result, this is ratio data. And this last one here, age groupings. So baby, toddler, adolescent, teenager, adult, and elderly. This is qualitative data. These are words and not numbers. These can be put in some order. For instance, if we wanted to order these from oldest to youngest or youngest to oldest, we could order these. As a result, this is ordinal data. All right, that's going to be it for the 1.1 video. I'll record separate ones for the rest of chapter 1.